right, so here we go. Acids and bases and salts. Oh my, this is day 3, Chemistry B, Unit 7. And this is going to be a shorter video than we've had in the last couple. So without further ado, let's giddy up. Alright, so what will make a solution an acid, or what makes that solution a base? Well, to be honest with you, it involves the concentration of hydrogen ions compared to the concentration of hydroxide ions. H positive compared to OH negative. So if the H plus concentration is greater than OH negative, the solution is acidic. If the H plus concentration is less than OH negative, then the solution is basic. And we also call basic solutions alkaline. So remember what concentration is. It's how much of the hydrogen ions or the hydrogen hydroxide ions are in the solution. So this tug of war takes place, or this battle. And if we have more H positive than OH negative, then we have an acid. If we have less H positive than OH negative, then we have a basic solution or an alkaline solution. If both of those are equal, then we have what is known as a neutral solution. Okay? Note, almost all solutions have some combination of both H positive and OH negative concentration in them. So whoever has more wins the battle. Now if you take a look at exactly how I've written this up here, I start off with saying if H positive is greater or H positive is less than OH. It's because it's the H positive that determines it. That is the number, that is the concentration that we look at when we determine whether it's an acid and base, which leads us into pH concepts. All right? It's a scale used to check acidity. 0 to 14, where 0 is strongly acidic, 7 is neutral, and 14 is strongly basic. Okay, the strict definition of pH is the negative logarithm of the H plus concentration. pH is equal to negative log HP. All right? The hydrogen ion concentrate of a solution is used to classify the solution as acidic, neutral, or basic, which is what I stated up here. And this is why it's listed as if H positive, if is less or greater, because it's the hydrogen ion concentrate of the solution that we are measuring. Okay? So here's a pictorial of the concentrations of H positive. We also will call this hydronium. So when we start looking at H3O positive, the hydronium ion, we also talk about it as H positive as well. So those are interchangeable. So if the H3O positive, which is basically the H positive, is greater, then we have a acidic solution. And it's no coincidence that this is red. Okay. Now this number over here is the actual numerical value for pH, and we're going to deal with that on a little, also. So if the concentration of H3O positive is greater than 1 times 10 to the negative 7, it is going to be a acid. If the concentration of OH negative is greater than 1 times 10 to the negative 7, then we are going to have a basic solution. So you can see that there. All right. Here are some common pH values, and down at the bottom of the screen, the program cuts off that last number, so I'll tell you right now what that is. That's 1 times 10 to the negative 14 for H positive, and that's 1 times 10 to the negative 1 times 10 to the 0 for OH negative. Okay? And as you notice, everything adds up to 14. Okay? If for example we have a concentration or a solution that is 1 times 10 to the negative 4, that means the OH negative concentration is going to be 1 times 10 to the negative 10. And that makes it a pH scale of 4. All right. 3 would be 1 times 10 to the negative 3, etc., etc. pH is 0.0 is hydrochloric acid. It is all HP with no H positive with no OH negative. And down here where you can't see, that's a 14, right in here below the 13. And that is 1 mole of NaOH, which is sodium hydroxide. Okay? Measuring pH. Knowing the pH of solutions is important. Pools, soil, medical, all right? And how do we do this? We measure it by using indicators. The indicator is actually an acid or a base that will undergo dissociation in a known pH range. This is valuable because its acid form and base form have different colors in solution. This should be a form, F-O-R, make sure that's form. Valuable because its acid form and base form have different colors in solution. And that's the end.